Hello and welcome to our mini topic on aqueous film-forming foams, or as they will often be referred to in this presentation, AFFFs. In this presentation, we will be going over what inspired us to present on this topic, what AFFFs are, the chemicals of concern, the source-effect chain pathway, local level concerns, other environmental impacts, related health issues, what is being done, related environmental health policies, and interventions and alternatives. We'll also provide a resources page, and finally, a discussion prompt. We chose this topic because it has recently been in our local news due to the discovery of groundwater contamination by a class of AFFFs in areas of Portland near Portland International Airport. One of these areas is a Portland Fire and Rescue Training Facility near the Columbia Slough. You can listen to the story here. What are AFFFs? AFFF is an acronym for Aqueous Film-Forming Foam. They are water-based firefighting foams used in extinguishing volatile liquid fires, such as petroleum fires and chemical fires. They can also be used as a way to prevent flammable liquids from combusting by blanketing the liquids until they can be cleaned up. AFFFs are used by fire departments and in firefighting foam suppression systems in places like chemical plants and airplane hangars. Take a look at NASA's foam suppression system test in the video on our resources page. AFFFs work by blanketing the fuel surface, smothering the fire, and separating the flames from the fuel surface. AFFFs are made up of mainly two chemical substances. The first is per- and polyfluoroalkyl substances, or PFAS. These are a class of anthropogenic or man-made substances that contain a combined form of carbon and fluorine. Perfluorooctanoic acid, PFO, and perfluorooctane sulfonate, PFOS, belong to this group of chemical substances, and you will hear them being referred to in this presentation as well. The second chemical substance is fluorosurfactants, which can act as detergents, wetting agents, emulsifiers, foaming agents, and dispersants. Fluorosurfactants and polyfluoroalkyl substances are persistent in the environment, meaning they don't break down. These are known as forever chemicals. The stability of these chemicals in the environment and in our bodies allow them to build up over time. This is called bioaccumulation. Studies suggest that these substances also biomagnify, which means they increase in concentration in the tissues of organisms as they travel up the food chain. In this source effect chain model here, the red ovals describe the major human exposure pathway of these anthropogenic chemical agents. Both food and soil could be included as transport mediums, as we will mention in a later slide, but for our specific purposes, we will just include water here. As we heard in the OPB story, aqueous film-forming foams are known to travel with rainwater and ultimately contaminate groundwater. Groundwater travels through the earth slowly, but in regions with heavy rainfall like Oregon, these chemical agents are able to migrate far from the point source. The areas surrounding the Portland Fire and Rescue Training Site, PDX, and the Portland Air National Guard Base, identified in the image by red circles, are areas where the foams are frequently used. These are the areas that have been contaminated. Without intervention, groundwater contaminated by these fluorosurfactants can contaminate drinking water wells. The image on the left illustrates the transport of contamination from point source, through groundwater, to drinking water wells, and finally exposures. Should a contaminated well go undetected, there's a risk that humans, animals, and plants could be exposed. As groundwater spreads, so does the contamination. Lakes, rivers, and streams, soil and crops, residential areas, and wildlife and vegetation are all at risk of contact. PFAS and PFOS have many human health risks. They have been linked to certain cancers like kidney and bladder cancers, as well as other health problems like reproductive issues and hormonal dysfunction. In addition to being in firefighting foams, these chemicals can also be found in items such as fast food wrappers, packaging, water repellent gear, and Teflon pans, to name just a few. This is especially concerning because of the frequency of these items in landfills. For more on this, please check out our resources slide. As you can see by these headlines, popular opinion is that the EPA could do a lot more to protect citizens from the hazards of these chemical agents. Under the Safe Drinking Water Act, the EPA can set maximum contaminant levels, or MCLs, of certain chemicals for drinking water. However, this monitoring applies to public water supplies only, not domestic drinking water wells, which are the most vulnerable. There are currently no EPA-issued regulations or MCLs for these forever chemicals in drinking water, but there are health advisories. According to the EPA, people shouldn't be exposed to a concentration of PFAS higher than 70 parts per trillion, but many health professionals say this is still too high. Because of the use of non-degradable fluorinated surfactants in firefighting foams and the frequent discoveries of contamination, environmental regulatory groups continue to investigate these chemical compounds. EPA lists these chemicals as emerging contaminants because of their evolving regulatory standards. Many state and local governments are drafting their own legislation to set standards and regulate the use of PFAS. Other countries have taken more aggressive actions against PFOS and PFAS and fluorinated firefighting foams. Both New Zealand and Queensland, respectively, have banned PFOS and PFAS, and Australia has banned fluorinated firefighting foams. In the U.S., under the Reauthorization Act of 2018, the FAA eliminates requirements that U.S. airports use fluorinated firefighting foam. In 2018, Washington became the first state to ban the sale of fluorinated firefighting foams. This ban takes effect in 2020. However, military, FAA-certified airports, petroleum refineries and terminals, and certain chemical plants will be exempt from the ban. And most recently, on February 14th of this year, the EPA issued a new PFAS action plan, though many critics say it falls short of actual protections from these toxins. There are only a few interventions and alternatives being used to reduce contamination of PFAS and PFOS. There are short-chain PFAS and fluorine-free foams, F3s. However, there are studies that show these alternatives still break down into the same compounds as the longer-chain PFAS and remain contaminants in groundwater. One suggestion is to have better bunding around training sites. A bund is a containment around an area where hazardous liquids are handled, processed, or stored. There are water treatment processes, activated carbon treatments, which only work well on longer-chain PFAS, ion exchange treatments, this process is expensive, and nanofiltration or reverse osmosis. These processes do not work in high-volume situations. One interesting alternative is an eco-friendly soap-based foam developed in collaboration between a Japanese soap company and the fire department of Kitakyushu City in Japan. This video explains the development and effectiveness of this alternative. Considering there are no hard and fast regulatory standards or exposure limits in place for these substances, we encourage you to dig deeper into this topic to learn steps you can take to lessen your exposure. Here we have linked you with additional information. And finally, our mini-topic discussion prompt. Despite the research and information available, why do you think the EPA is so hesitant to regulate or ban the use of PFAS and non-degradable fluorinated surfactants? Do you think special interests have something to do with it, or do you think it's a matter of safety?